Earth science time. The mic is on. I just got done telling Sydney that I'm not going to murder anyone. And I'm a man of my word, so I guess I won't. Today we're talking, let's call it paleontology in the brief. Paleontology, and it's going to be in the very brief. Not in the boxers, Camden. Paleontology, just some department store humor for everyone. Paleontology, let's forever spell it correctly though. So half of this video is me trying to get things right. Paleontology, gosh dang it, I did it again. 3/4 of the video, paleontology, there we go. The word has been, I'm going to try over. Paleontology, now that we've said it enough times to not make it not mean anything to anyone, what does paleontology mean? Yes, digging up fossils and stuff. I mean, really, that is exactly a study of, we could say, if we're going to phrase it that way, study of Earth's ancient history, specifically that regarding, especially life on Earth. We're going to talk about two things today. We're going to talk about lesson 2 from your book, which is, oh, Sydney, if you're already asking what does that say, you're going to have a rough time because it does not get better from here. Paleontology, study of Earth's ancient history. Come over here, please. Paleontology, study of Earth's ancient history. We're going to talk about this in 2 parts. Part 1 is going to be lesson 2 from your book, and I'm going to title that How It Be. And then we're going to have part 2, which is lesson 1 from your book, which is going to be How We Know It Be That Way. How we know it do be. Good. So how do it be? That's the first question. So just to make everything abundantly clear, we're doing lesson 2 from your book first, and then we're going to do lesson 1 from your book. This should all be review. We talked about all of this during, well, you should certainly be review for you because you took this in Mitchell. And also,
under part 1, lesson 2.
Part 1, lesson 2, how it be. Part 2, lesson 1, how we know it do be. This is going to be very in the brief because we're also going to watch a video that goes into a lot of detail about this, specifically the ages of things. And it's a review. This is going to be quite brief. I would say 3 out of 5 stars of brevity because it should be review and it's referenced in the video. We will talk more about it as we watch our professional quality video that is not made by a loser in a gray room. Okay, so part 1, lesson 2, how it be. How do it be though? That's my question. Regarding what is the it here and how it be. Again, what is the it in how it be? How do it be? Yeah, what's the it? What are we talking about? More specifically.
Life on Earth?
And specifically even more still.
Dinosaurs?
Dinosaurs, yeah. No, too specific. I'm talking about Earth's past, the history of Earth. History of Earth, or herstory. Just a little sexism joke for everyone. History of Earth. How do we break up the history of Earth? We usually talk about things like, in 2,465,619 BC, on July 3rd, the mastodon said to the coyote, no, we don't usually talk about that. How do we talk about Earth's history? We don't give it specific dates as we're used to dating. What do we talk about? We break it down into, we have what we call the geologic time scale. And we break it down into eons, eras, periods, and epochs. In England, in America, people say epochs. In Britain, they say epochs. I think epochs sounds cooler and faster, so I say epochs. The eons, let's start with that. The eons of Earth's history are, first of all, how old is planet Earth? How old does the evidence suggest planet Earth is? Yeah, billions of years, and I'm gonna get this as low as I can on still the camera. About 4.5 capital G capital A. Do you remember what capital G capital A stands for? Let's put a little side note over here, side note area.
What's that say? Eons or
Epochs, EPOCHs. Here's our side notes box. What's the capital G capital A stand for? Capital G capital A. Do you remember this from 8th grade science? Or do you remember it from your Earth science?
No.
Capital G capital A stands for giga onum. You don't remember this at all? And what is a giga onum? Giga onum. A billion years. 1 billion years. Giga meaning a billion. Like a gigabyte is a billion bytes, not quite, but roughly. A billion years. And then onum meaning years. We also talk about capital M capital A, which is mega onum. What do you think that is, if you had to infer?
Million.
1 million years. And then we'd also talk about lowercase k capital A. And what do you reckon that is?
100,000.
It's a kilo onum. What's kilo mean generally? 1,000 years. These are the usual divisions that we have. These are what I could say are the metric delineations of time. But we don't divide time up necessarily in that way. We have a geologic time scale, and we have in the eons column from 4.5 to about 0.5, so there-ish. I'm going to make this get quite a bit bigger, to about 0.5 gigaonum. How else could we express, using these, how else could we express 0.5 gigaonum? No, 540-ish. Not, I mean, it would be 500. 0.5 would just be 5. Well, I could put 4 there. 540 megaonum. Your face, Camden. Oh man, I wish the camera would track your face when you did that. 540 megaonum. Okay, so 0.54 gigaonum to be clear, then about 540 megaonum, and we call this time between these the Precambrian time, or we sometimes call it the Proterozoic. Proterozoic eon. And the Proterozoic eon is also divided into the Hadean and the Archean. Oh, I'm sorry. Actually, I was wrong. Your book calls this all Precambrian time. Precambrian time. Before Cambrian-Vogel. Just kidding. Precambrian time. But it's also broken up into the Hadean, Archean, and Proterozoic. These you don't have to worry about too much. This word is more important. The Precambrian is more important. It's a group for all of these. And then we talk about the Phanerozoic. Phanerozoic eon, which is everything since 540 megaonum. And then we're going to divide if I do this, does this make sense to you? Do you understand that I'm talking about, this line just represents the Phanerozoic. So I'm actually going to do it in a different color too. I'm going to label these in different colors also. The Phanerozoic, and the Phanerozoic is going to be just this part, and I'm going to call it, we divide the Phanerozoic into these, for crying out loud, I don't mean to write Phanerozoic there, eons, eras. I'm going to write eras. And the eras within the Phanerozoic are the Paleozoic, which began when, can you guess from my previous thing I said? When did the Paleozoic era begin? Well, we're only talking about the Phanerozoic here, so this dividing line. Yep. So it's also 540 megaonum, or 0.54 gigaonum, is the Paleozoic, and that lasted until 252 megaonum, and then the Mesozoic began, and that lasted until 65 megaonum. Why am I putting the older things on the bottom? Because they're older, because it's just like a stratigraphic sequence. The oldest thing is on the bottom. What do we call that principle? That's going to go in this box. Actually, we can write it now. What do we call that principle? How we know how it be? It's a vocab word. The principle that says the oldest rock is on the bottom. Okay, so relative age dating. We're going to have that in a second. Relative age dating. And one of the things in relative age dating is superposition, which basically says the oldest material is on the bottom. That's the most basic principle of, but we're going to talk about that in a second. And then with the Mesozoic, what happened here? What big event happened at 65 mega on them that we know about and is important? Yeah, the asteroid impact that killed the dinosaurs. So, and that began the Cenozoic era. And then we further break up the eras, and these are not going to be a subsection. I'm just going to come straight across. We further break up the eras into periods. You better get out your tiny pen for this. The Paleozoic, from 540 to about 485. 485. These are all going to be in mega ana. We have the Cambrian, or what other people, I think everyone in the world except for me, calls the Cambrian. The Cambrian, then the Ordovician went until 444. Ordovician, this is the source for this at the moment. This is well established. The one I will hand out is from 2009, the Geological Society of America meeting. But the source that I'm currently using is this part of your book or your explorations. Let's get it on camera. You can pause it. It's a kind of nice view of the geologic timescale. Anyway, okay. So you can look that up too and have it here with you, and you can write it like a normal person. Ordovician, which lasted until 419, and that area was called, this next one, which lasted until 419, was called the Silurian. When I say 419, do I mean 419 AD or BC? What am I talking about? What's 419 here? Just as a reminder. Mega on. This many million years ago. 419 million years ago. And then that lasted until 359, or sorry, that lasted until 419, and then the Devonian lasted until 359. All this should be going in the Paleozoic. And the Mississippian began, and that lasted until 323. Mississippian, M-I-S-S-I-S-S, I-P-P-I-A-N, Mississippian. Then the Pennsylvanian was until 299. Pennsylvanian until 299, and then the Permian ended in 252. And that all fits into here. So when I said I'm not going to make a subsection, I actually did. Nice. Then we'll do the Mesozoic in a different color. The Mesozoic is quite a bit easier. We're going to have this one be green, and I guess I'll shove it over here. So when did the Mesozoic begin in Mega Ana? Yep, you're right, 252. And it went until 65. Thank you, yep. I was momentarily confused. The Triassic lasted until 201 Mega Annum, which is when the Jurassic began. And that lasted until 145. And then the Cretaceous began, and that lasted until the extinction of the non-avian dinosaurs in 65 Mega Annum. And then the Cenozoic era began, which I'm going to do in Cenozoic. And then the Cenozoic is composed of these periods. We usually call it the Paleogene, and the Neogene is the current methodology. The Paleogene began at 65 Mega Ana and lasted until 23 Mega Ana. Paleogene. And then the Neogene began. And then we consider this very end part here the Pleistocene. Apparently, your book says Pleistocene and Holocene, but there's this era up here called the Quaternary. Quaternary. Which began 2.6 megaannum. Sorry, I had a hard time reading that. The reason this is called Quaternary, can you guess what that quater might relate to? I think it might actually be Quaternary. It is. Basically, this was called the Quaternary. This was called like the fourth thing. These two together were called the Tertiary, and then the Mesozoic was called the Secondary, and this was called the Primary. We no longer use that. We stopped using that a long time ago, but the Quaternary kind of became it's a holdover from then. And then these are further broken up into, and you can look at the epochs on your own. They're in that book too. We aren't going to worry too much about those, but the epochs or epochs of the where did I even write it? Cenozoic. The epochs of the Cenozoic are written in your book. So what we're going to do is when we haven't learned anything about the events of this. Your book goes into quite a lot of depth about the events, but instead of doing that here, I just wanted to illustrate this to you, and then we're going to watch the events in the video, and you're going to consult this, which I'll give you a neater version of this. It'd be nice if you still wrote this down, because that way you get it kind of... It is my true opinion that if you write something, it helps you remember it. Once again, that's my opinion, but I will give you a neater version of this that the Geological Society of America publishes, and then we'll consult this, and then when I give you in reference with the video to kind of learn about what the events were. Questions about this? So, how it be? This is how it be. Geologic time is broken up. Oh, and by the way, one last thing before we move on to how we know it do be that way. What is the dividing line here? This was the 31st of December, and so it rolled over into the Cenozoic? No, what's the dividing line? Yeah, some mass extinction event, usually, almost always, a mass extinction at these demarcations. And why would we use a mass extinction? Why not just make them all the same? Like, this one is 24 megaannum, and this one is 36. Why would we not just make them all the same distance? What's better about using mass extinctions, which obviously are somewhat random? I mean, it's semi-periodic, but... Yeah, because that's what we have evidence of. That's what actually happened. So we use real physical pieces of evidence to say when the end was. It's still somewhat arbitrary. It's still human beings deciding, oh, this one was important enough that it makes a new era. This one was important enough it makes a new era, and this one was not, etc. So it's still somewhat arbitrary, but it is based on how we know it be that way. What's the short answer, Camden and Sydney? What's the short answer for how do we know it be that way? Evidence. It's just evidence. Yeah, the evidence. And what are some examples of evidence? Fossils. That's the biggest one, usually. What else?
Geology.
Yeah, geology. Pretty much that's it. Fossils and geology are the evidence that this is how it is, that it is this old, and that these are the times when it occurred. In order to leave this up here, I'm just going to relate the lesson 1 stuff to you, which is relative age and absolute age dating. So the first and most basic principle is superposition. Superposition is just that in an unoverturned, which means it hasn't been jostled around by plate tectonics too much, in an unoverturned sequence of rocks, the oldest rocks are on the bottom. This is true too of, the example I always use is if you have a nice pile of, well, you're all girls, so this doesn't really apply to you, but of smelly laundry in your room. And instead of washing it, you just leave it there to fester, like teenagers do, or at least teenage boys do. And you think, oh, I've got a date at Arby's pretty soon. I need to find my nice shirt that I wore 3 weeks ago. Where are you going to look for the thing that was 3 weeks ago? Assuming this is today's dirty laundry, where are you going to go to find 3 weeks ago's laundry? The bottom, the further down. I mean, I have no idea how old your laundry pile is. Like, if this is 6 years old, 1, that's pretty bad, but also 3 weeks is not that far down. But it's probably not. Assuming that your laundry gets done once a month, your month-old stuff is down here. Let the record show that is not how often at our house we do laundry, but I know there are teenagers who do laundry once a month, and so the month-old stuff is down here. This is the most recent stuff. It's true of all things. It's not just geology. If I have a pizza, what did Luigi at the pizza place have to put down first? Here's my pizza sauce. Here's the cheese. Here's the pepperonis. Here's the olives. What did he have to put down first? Well, he had to have the crust first, then the sauce, then the pepperonis. Well, you can just tell because that's the order it was. Is it possible for Tony Luigi. Tony's our classmate. Luigi is the pizza guy. Tony's our classmate. Is it possible for Luigi to have done this all and then flipped it upside down? Yeah, of course. Is it possible to have a giant pile of laundry in your room and then flip it over so this is no longer true? Yeah. Is it possible for the oldest rocks not to be on the bottom? Yeah, it still is. It's unusual, right? It takes extra energy for that to occur, and so this is the rule, although there are exceptions. This is the rule, although there are exceptions. The other principles of superposition, of relative age dating. Oh, and when I say relative age dating, do I mean talking about going to your family reunion and picking up chicks? Yep. Good. In the video. No. What do I mean by relative age dating? Is there room for... Yeah, relative age dating equals the age of a particular object related to other objects. So I'm not talking about 3-week-old laundry. I'm talking about the oldest laundry. I'm not talking about that he put down the pepperoni 30 seconds ago and the sauce 45 seconds ago. I mean that the pepperoni is more recent than the sauce. Same thing, I'm not necessarily talking about these rocks being 65 million years old at this point. I'm talking about them being more recent than rocks that are underneath them. It's as the ages relate to one another. What are the other principles of relative age dating? Well, there's something called lateral continuity, which is where that we assume when rock layers are laid down, they're laid down in a flat, continuous line. So then any kind of valleys or ridges that they develop are secondary to that. So the valley or the ridge must be newer than the rock itself. There's also the idea of cross-cutting relationships, where if we have layers of rock and a fault goes across them, the fault must be more recent than the rock, because you can't have a rock with a fault in it and the fault is newer than the rock, or the fault is older than the rock. It doesn't make any sense. And the other one is inclusions, which is the same thing. You can't include pieces of rock in another rock if the inclusions didn't already exist. So the inclusions are always older than the rock itself. And then for absolute age dating, which is the last thing we're going to have time to talk about, absolute age dating, how does this... What is this like? What is absolute age dating? Numeric age. Don't be confused. When it says absolute age, it does not mean the exact age. It doesn't mean this is 65,419,621 years, 72 days old. It's not the exact age. It just means a number age. There's all different ways to figure it out, but the best way is the radioactive. Once again, the bell ring, but all of this is the surface level stuff. In order to get the minutia that you need to pass the test into a good... I think this would let you pass the test, but to do a good job and get an A on your test, you need to read this.